Welcome to Keentel Engineering. Today, we're breaking down IEEE 2800, the standard reshaping how solar, wind, and battery storage projects connect to the grid. 8 compliance phases, 20 questions answered in the full white paper, 3 real-world case studies, and 3 decades of transmission and distribution engineering behind every page. Inverter-based resources, solar, wind, and battery storage now make up a huge and growing share of what's connecting to the grid. Unlike traditional spinning generators, they carry almost no physical inertia. When something goes wrong on the system, they react in milliseconds, not seconds. IEEE 2800 to 2022 sets uniform performance requirements for how these resources have to behave. And here's the part that catches people off guard. If you own the project, compliance is your responsibility, not your equipment vendors, not your EPC contractors. You can hand off the work, but you can't hand off the accountability. The grid was built around large spinning generators. That spinning mass stores energy physically. It buys the system time during a disturbance and naturally pushes back against voltage and frequency swings. Inverter-based resources don't work that way. They connect through power electronics with no spinning mass at all. Every response to a disturbance is a software decision made in milliseconds, fast and precise, but capable of correlated system-wide failures. That risk became real. Events where thousands of megawatts of solar tripped off simultaneously from a single routine fault pushed NERC and an industry working group to create IEEE 2800. It was approved in 2022. 6 players share this process. The generating owner owns the resource and carries responsibility for design conformance and proof of compliance. The generating operator monitors and runs the resource day to day. The transmission system owner designs, builds, and owns the facilities the plant connects to. The transmission system operator runs the grid in real time and approves test procedures. The authority governing interconnection decides whether and how the standard applies in your region. And the verification entity is the independent expert who witnesses testing and signs off that the proof is real. 3 ideas make the rest of this standard click into place. First, it's a performance standard, not a design standard. It tells you how the plant must behave, not which equipment to use. Second, everything is measured at the reference point of applicability, judging the aggregate plant as a whole rather than any single piece of equipment. And third, this is a lifetime obligation. A firmware update, a hardware swap, or a setting change can re-trigger verification for decades to come. IEEE 2800 is a performance standard, not a checklist. It tells you how the finished plant must behave, then requires you to prove it, on paper and in the field, across reactive power, frequency response, ride-through, power quality, protection, and modeling. Every generating owner works through the same 8-phase journey. Understand which rules actually apply to your project. Register the plant's ratings. Design for the required capabilities. Prove it on paper through design evaluation. Build the plant to match that design. Demonstrate performance in the field during commissioning. Validate your models against real-world results. And, finally, operate and monitor for the life of the plant. It's not a box you check once. It's a program you run for decades. On reactive power and voltage control, plants must inject and absorb reactive power equal to at least about 1/3 of their rating, roughly a 0.95 power factor, while still delivering full active power. Response has to start within 200 milliseconds of a voltage step, settling with a damping ratio of at least 0.3. On frequency response, primary frequency response uses automatic droop, commonly around 5%, with adjustable deadbands for under and over frequency events. Fast frequency response leans on inverter speed where it's required, and storage can respond in either direction, charging or discharging. This is the heart of the standard. Above 1.20 per unit voltage, a plant may ride through or may trip. Between 1.10 and 1.20, mandatory operation for at least 1 second. Between 0.90 and 1.05, continuous operation. No exceptions. Below 0.90, mandatory operation for 3 to 6 seconds, depending on auxiliary limits. And here's the line that matters most. If a plant trips because of its own protection while it's inside a defined ride-through envelope, that's non-compliance. Full stop. Let's recap the numbers that define this standard. 33%, the minimum reactive capability required, relative to rating. 200 milliseconds, the ride-through response window, 8 compliance phases to work through, 20 FAQs answered in the full white paper, a 90% false trip reduction in one featured case study, and 30-plus years of transmission and distribution engineering experience behind this guidance. Let's answer some of the most common questions we hear about IEEE 2800. What exactly is IEEE 2800, and is it mandatory? IEEE 2800-2022 defines the technical minimum performance requirements for inverter-based resources. On its own, an IEEE standard is voluntary. It becomes mandatory once a regulator adopts it or a utility writes it into interconnection requirements. Across North America, it's rapidly becoming the de facto requirement for new transmission-connected inverter-based resources. How do you know if it applies to your project? Applicability is set by your regional authority and your utility. Confirm it in writing with your interconnecting utility early, because that answer drives your entire design basis. Who is actually responsible for compliance? You, your inverter vendor, or your EPC? It's you, the generating owner. IEEE 2800 names the IBR owner as responsible for conformance. Vendors supply capable equipment, and your EPC builds to a design. But assembling the proof that the whole plant performs and maintaining that proof for life is on you. Your inverters are UL 1741 certified. Doesn't that make your plant compliant? No. Equipment certification is explicitly outside the scope of IEEE 2800 compliance. Certification tells you an inverter behaves a certain way at its terminals. IEEE 2800 is judged on the aggregate plant at the reference point. After transformers, cables, losses, and the plant controller have all had their effect, certified equipment is necessary, but it isn't sufficient on its own. What is the RPA, and why does it keep coming up? The reference point of applicability is the specific electrical location where a requirement is measured. By default, the point of measurement, usually near the point of interconnection. It matters because performance at an inverter's terminals is very different from performance at the plant boundary. What does ride-through actually require your plant to do? It requires the plant to stay connected and keep supporting the grid through voltage and frequency disturbances that fall inside defined envelopes. During faults, it must inject reactive current to support voltage. If it trips inside those envelopes, that's non-compliance. What is reactive power capability, and how much do you need? Reactive power holds voltage steady. IEEE 2800 requires your plant to supply and absorb reactive power equal to at least about a third of its rating while producing full active power, all measured at the RPA, so the plant has to be engineered to deliver it right where it's measured. Do you really need an EMT model, even though they're expensive? Often, yes, especially for weak grid interconnections and for verifying ride-through. EMT models capture fast, detailed interactions that simpler models miss entirely. The expense is small next to the cost of a failed design evaluation or a restudy delay. What is a weak grid, and why does it complicate everything? A weak grid has a low short-circuit ratio, common at remote, high-renewable locations. Inverter controls can interact with the network in unstable ways, demanding the most careful EMT modeling, control tuning, and sometimes supplemental equipment. How early should you bring in an engineering firm? As early as the feasibility and interconnection application stage, before the design is locked. The cost of expertise early is small next to the cost of waiting, failed design evaluations, restudy delays, missed energization dates, and expensive redesigns. Let's talk about what it actually takes to connect a solar, wind, or storage plant to the grid today, because the rules changed and a lot of developers haven't caught up. IEEE 2800-2022 exists because inverter-based resources behave nothing like the spinning generators the grid was built around. A coal or gas plant responds to a fault based on physics understood for a century. Inverters respond based on software. And when thousands of them react identically to the same disturbance, that's a system-wide risk, not a local one. The standard sets uniform performance rules to fix that. Here's the part every developer needs to hear. Compliance sits with you, the generating owner, not your inverter vendor, not your EPC, not the utility. A certified inverter is a building block, not a finished compliant plant. Everything gets judged at one specific location, the reference point of applicability. looking at the aggregate plant near the point of interconnection, not any single inverter's nameplate spec. That's why ride-through sits at the heart of the standard. Trip inside the defined voltage envelope, and that's non-compliance? Full stop. Plants have to inject reactive current through the fault instead of dropping offline. Getting there takes real engineering, EMT modeling to catch weak grid and ride-through issues before they become expensive redesigns, and careful attention to reactive power capability, since it can erode significantly between the inverter terminals and the RPA. And compliance doesn't end at commissioning. Firmware updates, hardware swaps, even setting changes down the road can re-trigger verification requirements. This is a decades-long program, not a one-time certificate you file away. If your project needs IEEE 2800 design evaluation or EMT modeling support, Keentel Engineering can help. Visit KeentelEngineering.com. Thanks for watching.